This is going to be our notebook entry for step functions. First, we're going to start with our definition, which should be on your notebook page. So step functions have a graph that is a series of line segments, and when we get there to our example, that's going to make a little bit more sense, and you'll be able to see what that means. Before we start, we need to go over what an open circle and a closed circle means on a graph. It's something that comes from inequalities that we learned in middle school math. So just to refresh our memory, on a graph, if we use an open circle, that means that the value can get close, but it cannot equal. Okay, so for example, if you put an open circle on 5, that means you can have 4.999 forever, but it cannot be 5. And then the other option would be a closed circle. So if we have a closed circle on the graph, that means that the value is equal to that number. Okay, so now we're going to use that idea for our example here. So our example says a tour bus company has buses that can each hold up to 20 passengers. We're going to make a step function to model how many buses are needed for any number of passengers. So we're going to start by talking about our x and y variables. So our x variable is going to be our independent variable. For our situation specifically, that's going to be how many people are going to be on that bus. So underneath here, we are going to write number of people. Okay, and then our dependent variable is going to be our number of buses, because the number of buses is going to depend on how many people we have. Okay, so now we're going to go ahead and make a table, and we're going to kind of talk about some different values and how many buses we would need. So we're going to start off with 0. If we have 0 people riding on a bus, we obviously need 0 buses. Okay, then our next entry, if I have 1 person that's going on this tour, we are going to need 1 bus. And then if we pick a number kind of in the middle of 0 and 20, so if we pick like 12 people are still going to need that 1 bus. And then if we go up to that 20, we are still going to need 1 bus. Okay, but as soon as we have 21 people, we're going to need to bump up and we're going to need to use 2 buses until we get to 40 people. And then as soon as we jump over 40, we're going to need 3. All the way until we get to 60. And then after that, we're going to need 4, and that pattern is going to continue forever. Okay, so what I'm going to do now is I'm going to make my scale on my graph. The x-axis, I'm going to spread it out a little bit, but I'm going to count by 20s. So let's skip a couple tick marks here. And then we have 20, 40. Okay, and then up the side, we're going to count by 1s, but again, we're going to spread it out a little bit so that we're not so squished. All right, so now we have our graph to make. So 0, 0, we would have a point down here at the origin. So 0, 0. Okay, and now this is where the open and closed circles come into play. So for our first number of buses here, so we have from 1 to 20 is 1 bus, but there's no way to actually graph 1. So what we're going to do is we're going to put an open circle at the point 0, 1. And then we're going to stay at 1 bus all the way to 20 people. So that's going to be a closed circle, and then that horizontal line. Okay, and then at 21 people, so we're going to put that open circle at 2. We're going to need 2 buses all the way to 40 people. Okay, and then again, that jumps up to 3 buses all the way until 60 people. And then that pattern would continue forever. So you can see, looking at the graph, it's called a step function because our lines here look like stairs. You can see that it has a series of line segments. So it starts with an open circle, closes with a closed circle. It's not always going to be like that. You're going to have to make sure you pay attention to the scenario and reason through it, but you will always have one side with an open circle and one side with a closed circle.